Welcome to the Sleepy Science channel. Here, we use soothing sleepy bedtime science stories to unveil the tranquil mysteries of the universe for you tonight. Let's relax our minds and embark on a gentle journey into a world of science and dreams. Surrounded by the 432 Hz Earth frequency, today, we embark on a magnificent interstellar journey. Our destination is a home both familiar and strange. The solar system. Please fasten your seatbelts and steady your breath. Our journey begins now. First, let's take a bird's eye view of the entire solar system. It is not overcrowded, but is emptier than you can imagine. The sun is the absolute master and energy source of this domain. Its mass accounts for a staggering 99.86% of the total mass of the solar system. This is an astonishing figure. It means all the planets, moons, and asteroids combined make up a mere 0.14%. The sun's gravity acts like invisible reins, firmly guiding all members of its family. In their orbits around it, the members of this family can be roughly divided into several groups. Innermost are the 4 rocky planets composed mainly of rock and metal. They are Mercury, Venus, Earth, and Mars. They are relatively small, dense, and very close to the sun, like children huddled around a warm stove. Further out, beyond a belt of rocky debris known as the asteroid belt, we enter the realm of the gas giants. This is the domain of Jupiter and Saturn. They are enormous, composed primarily of hydrogen and helium, with no solid surface to stand on. They are the giants of the solar system. Continuing outward into the colder depths of space are the twice giants Uranus and Neptune. They possess cores made of icy materials, shrouded by thick atmospheres. They appear more serene and azure. Beyond the orbits of all these known planets lies the vaster frontier of the solar system. Here resides the Kuiper Belt and the more distant, hypothetical Oort cloud. This is the home of countless icy bodies, including our familiar Pluto, now classified as a dwarf planet. The entire domain of the solar system may span up to light years in diameter, a number that makes us feel incredibly small. 1 light year is the distance light travels in 1 year, approximately 9.46 trillion kilometers. Our solar system is just such an unremarkable world, located in a spiral arm of the Milky Way, yet utterly unique to us. Now, let's focus our gaze on the center of the solar system, the sun. It is not the brightest star in the sky, nor the largest, but it is the source of our life. Without it, everything on Earth would cease to exist. At its core, the sun is a star, a massive, incandescent ball of gas. Its main components are hydrogen and helium. In its core occurs the most fundamental and grand process in the universe, nuclear fusion. Every single moment, millions of tons of hydrogen nuclei collide and fuse under immense temperature and pressure, forming helium nuclei and releasing unimaginable energy. This process can be understood through the famous mass-energy equivalency equation, T = mc. Tiny amounts of mass loss are converted into colossal energy. The temperature at the sun's core reaches 15 million degrees Celsius. The pressure is hundreds of billions of times greater than Earth's sea level pressure. It is in these extreme conditions that the fire of nuclear fusion burns continuously. The sun's energy, in the form of photons and various particles, makes its way from the core to the surface. This journey can take tens of thousands of years. Finally, the energy radiates into space as light. The sunlight we feel actually departed from the sun's surface just 8 minutes ago. It has traversed 150 million kilometers of cosmic vacuum. To warm our skin, the visible surface of the sun we see is called the photosphere. Its temperature is about 5,500 degrees Celsius. It is not smooth as a mirror, but covered in granulation. These granules are actually convection cells of hot gas rising, cooling, and sinking. Each individual granule can be larger than the entire Earth. Above the photosphere lie the chromosphere and the corona. The corona is the sun's outermost atmosphere. It is exceptionally thin, but its temperature soars to millions of degrees Celsius. This remains a major puzzle in solar physics. Known as the coronal heating problem, the sun is not always tranquil. Its surface often exhibits activity, such as sunspots. They are regions where magnetic fields are concentrated, slightly cooler than their surroundings. Hence they appear dark. The number of sunspots follows a cyclical pattern of approximately 11 years. This is known as the solar cycle. There are also more violent solar flares and coronal mass ejections. They are like the sun's superstorms, capable of releasing energy equivalent to billions of hydrogen bombs in an instant, hurling vast amounts of high-energy charged particles into space. When these particles reach Earth, they interact with Earth's magnetic field, producing the brilliant aurora, but sometimes they can also disrupt our satellites and power grids, making us acutely aware of the intimate connection between solar activity and our lives. The sun has been burning for about 4.6 billion years. It is in its stable middle age, a phase we call the main sequence. Scientists estimate its hydrogen fuel is sufficient for another 5 billion years. Then it will enter its late stages, expanding into a red giant. Eventually it will shed its outer layers, forming a beautiful planetary nebula, while its core collapses into a dense white dwarf, slowly cooling and fading away. Of course, that is an exceedingly distant future. We need not worry about it now. Leaving the sun, our first stop is the planet closest to the sun, Mercury. Its name comes from the Roman mythology of the swift-footed messenger. This is very fitting, as it truly is the fastest planet in the solar system. It takes only about 88 Earth days to complete one orbit around the sun. In other words, a year on Mercury is less than 3 months on Earth. Due to its proximity to the sun, Mercury's environment is nothing short of hellish. The side facing the sun can see temperatures soar to 430 degrees Celsius, hot enough to melt lead and tin. On the night side, facing away from the sun, with no atmosphere to retain heat, the warmth rapidly dissipates into space, and temperatures plummet to minus 180 degrees Celsius. The temperature difference between day and night exceeds 600 degrees, making it the planet with the greatest temperature variation in the solar system. Mercury has almost no atmosphere, just an extremely tenuous one captured from the solar wind. and dust kicked up by micrometeorite impacts without the protection and moderation of an atmosphere. It is directly exposed to solar radiation and meteorite impacts. Its surface is covered in craters, making it look remarkably similar to our moon. Mercury's topography consists mainly of three types. The first is the ubiquitous craters and basins. The most famous among these is the Calorus Basin. This is a giant impact crater about 1,550 kilometers in diameter, formed by a cataclysmic collision early in the solar system's history. The shockwaves from this impact even traveled throughout Mercury, creating weird, hilly terrain directly opposite the basin. Known as the weird terrain, the second is plains they formed from the solidification of an ancient magma ocean, filling in the earlier giant impact basins. The third is the surprising scarps or lobate cliffs. They wind for hundreds of kilometers and are kilometers high. Scientists believe these formed as Mercury's core cooled and contracted, causing the crust to compress, fracture, and thrust over itself. This tells us that although Mercury is small, its geological history is quite complex. Mercury has a puzzling characteristic. It possesses a massive iron core. This core makes up nearly 85% of its radius. In comparison, Earth's core is only about half its radius. This means Mercury's mantle and crust are relatively very thin. Why does Mercury have such a large iron core ratio? This remains an unsolved mystery. The leading theory suggests that early in the solar system's history, a massive object might have collided with Mercury, stripping away most of its mantle material, leaving behind this big iron blob. Despite such a harsh environment, humans have still sent probes to visit it. NASA's Messenger probe orbited Mercury from 2011 to 2015. It sent back a wealth of precious data and images, completely transforming our understanding of this mysterious planet. Bidding farewell to Mercury, we fly to the next stop. Moving outward from the Sun, the second planet is Venus. It is often called Earth's sister planet because they are very similar in size, mass, density, and composition. However, the fates of these two sisters diverge drastically. Venus embarked on a path of runaway greenhouse effect. Venus is tightly wrapped in a thick, dense atmosphere. This veil is composed mainly of carbon dioxide. The atmospheric pressure is 92 times that of Earth's at sea level, equivalent to the pressure 1,000 meters deep in Earth's ocean. If you stood on Venus's surface, you would be both crushed and roasted. This carbon dioxide atmosphere creates an intense greenhouse effect. It acts like a thick blanket, trapping the sun's heat firmly. This results in an average surface temperature on Venus of 462 degrees Celsius, the highest of any planet in the solar system, much hotter than Mercury, which is closer to the sun. Furthermore, there is almost no temperature variation between day and night, or equator and poles. It is a monotonous, scorching, high-pressure world of terror. The upper atmosphere of Venus also contains thick clouds composed of sulfuric acid droplets. These clouds are highly reflective, making Venus the second brightest object in the night sky. After the moon, the morning star or evening star we see is Venus. But these beautiful sulfuric acid clouds produce acid rain. However, due to the extreme surface heat, The acid rain evaporates before reaching the ground because the clouds are so thick we cannot see its surface directly with optical telescopes. It wasn't until the development of radar technology that we could penetrate this veil and glimpse its true face. Venus's surface is mainly rolling plains, dotted with a few vast highland regions and some massive volcanoes and canyons. The most prominent features on Venus are volcanoes. Its surface is covered with thousands of volcanoes, some of which are likely still active. Volcanic activity is likely one reason for maintaining its thick atmosphere. Additionally, there are large coronae structures formed by mantle plumes upwelling and pushing the surface upwards. There are also crisscrossing fracture zones, indicating that Venus's crust has experienced intense tectonic activity. An interesting fact is Venus's rotation is very peculiar. It is not only one of the slowest rotators in the solar system. A Venusian day equals to 143 Earth days, but it also rotates backwards. That means on Venus, the sun rises in the west and sets in the east. Why is this so? It might have been tipped over early in its history by a large impact. The history of Venus exploration is filled with poignancy. The Soviet Venera series of probes attempted landing multiple times. In the extremely hostile environment, they survived for at most 2 hours before losing contact with Earth forever. But the data and photos they sent back were the first, and so far the only, precious information obtained from the surface of Venus. Venus hangs in the sky like a mirror, warning us of the terrifying consequences of a runaway greenhouse effect. It might have once possessed oceans, but, due to runaway feedback, became the hellscape it is today. Studying Venus means studying a possible future for Earth. Leaving the suffocating Venus, we finally return to our unique home in the universe, Earth seen from space. It is a beautiful blue planet, adorned with white swirls. Against a deep black background, it emits a gentle glow. It is currently the only known planet in the universe that harbors life. Earth's ability to become an oasis for life is the result of a series of coincidences and necessities. First, its location in the solar system. It resides in the habitable zone, the Goldilocks position. Not too close, not too far from the sun, it receives just the right amount of solar radiation, allowing water to exist stably in liquid form on its surface, and liquid water is widely considered a prerequisite for life. Second, it possesses a global magnetic field. This magnetic field is generated by the motion of liquid iron in its outer core, a process we call the dynamo effect. This magnetic field acts like a protective shield, deflecting the powerful stream of high-energy charged particles from the sun, known as the solar wind. Without this magnetospheric protection, Earth's atmosphere would be gradually stripped away by the solar wind, and life would be exposed to lethal radiation. Third, it has an atmosphere with a suitable composition and moderate thickness, composed mainly of nitrogen and oxygen. It provides the breath of life, regulates surface temperature, and blocks most harmful ultraviolet radiation. Earth's internal structure is quite typical. From the inside out: core, mantle, and crust. The core is divided into a solid inner core and a liquid outer core. The mantle is a thick layer of solid rock that slowly convects. The crust is the thin, rocky shell we live on. Earth's interior is active. Mantle convection drives the motion of the crustal plates, a process we call plate tectonics. Plate tectonics is the primary force shaping Earth's surface. It creates majestic mountain ranges, deep ocean trenches, and is responsible for frequent earthquakes and volcanoes. But on a grander scale, it facilitates the cycling of geochemical materials, playing a crucial role in regulating global climate and maintaining long-term stability for life. About 71% of Earth's surface is covered by oceans. These vast oceans are the cradle of life. They absorb and store heat, regulate global climate through ocean currents, generate the oxygen we breathe, and are an indispensable part of Earth's ecosystem. Beside Earth orbits a unique natural satellite, the Moon. Its diameter is 1/4 of Earth's, and its mass is 1/80th of Earth's. This ratio is very special in the solar system. Therefore, the Earth-Moon system is sometimes considered a double-planet system. The Moon's influence on Earth is profound and significant. The most direct is its tidal force, causing the ocean's tides on Earth. This tidal friction is also gradually slowing down Earth's rotation while causing the Moon to recede from us by a few centimeters each year. The Moon's gravity also helps stabilize Earth's axial tilt, ensuring that Earth's climate over long geological timescales remains relatively stable, avoiding extreme fluctuations. This provided the precious time needed for life to evolve and flourish. The Moon itself is also a world full of stories. Its surface is covered with craters, witnesses to the violent bombardment here early in the solar system. It is divided into bright highlands and dark maria. The maria are actually vast plains of basalt, formed by ancient volcanic eruptions. Regarding the Moon's origin, the most widely accepted theory is the giant impact hypothesis. About 4.5 billion years ago, a Mars-sized body named Theia collided with the primordial Earth. The debris from this impact coalesced in orbit around Earth, eventually forming today's Moon. This theory explains well why the compositions of the Moon and Earth are so similar. Gazing at the stars from Earth, the Moon is our closest neighbor. It is also the only extraterrestrial body humans have set foot on to date. It carries our dreams and is the first stepping stone for our journey into the deeper cosmos. With nostalgia for our home, we continue outward. Crossing the asteroid belt, we arrive at the fourth planet. It has captivated countless gazes with its fiery red colored. It is Mars, the red planet. Mars's red hue comes from iron oxide widely distributed on its surface, commonly known as rust. Its soil and rocks are rich in iron over billions of years. This iron reacted with oxygen and water vapor in the thin atmosphere, forming red iron oxide that covers the entire planet. In the history of solar system exploration, Mars is undoubtedly the most studied planet after Earth because it is the most Earth-like planet in terms of environment. Although it appears cold, dry, and barren now, substantial evidence indicates that in ancient times it was warm and wet, possibly even hosting oceans and rivers. From photos sent back by orbital probes, we can clearly see dried up riverbeds, remnants of lakes, vast alluvial plains, and teardrop-shaped islands. These clearly tell us liquid water once flowed freely on the surface of Mars. So, where did the water go as Mars lost its magnetic field? The solar wind stripped away most of its atmosphere. The atmosphere became thin, pressure dropped, making it impossible for water to exist stably in liquid form. It either evaporated and escaped into space or exists as ice, trapped in the polar caps and subsurface permafrost. Mars's current environment is very harsh. The average surface temperature is minus 63 degrees Celsius. The atmosphere is extremely thin, composed mainly of carbon dioxide. The atmospheric pressure is less than 1% of Earth's, and there is no global magnetic field for protection, leaving it directly exposed to solar and cosmic radiation. Despite this, Mars's north and south poles still have polar caps made of water ice and dry ice solid carbon dioxide. They grow and shrink with the seasons. Furthermore, underground on Mars, large reserves of water ice have been discovered. This water is a crucial resource for future human landings on Mars. Mars's topography is diverse, varied, and awe-inspiring. It boasts the tallest mountain in the solar system, Olympus Mons. This is a shield volcano, over 21 kilometers high, almost 3 times the height of Mount Everest. Its base diameter is about 600 kilometers, almost the size of France. It also has the longest canyon in the solar system, Valles Marineris. This is a massive rift system, over 4,000 kilometers long, 200 kilometers wide, and 7 kilometers deep. If placed on the United States, it would stretch from the east coast to the west coast. Its formation is likely related to the stretching and collapse of the Martian crust. Mars has two natural satellites, Phobos and Deimos. They are irregularly shaped, like captured asteroids. Phobos is slowly moving closer to Mars, and in tens of billions of years might crash into Mars or be torn apart into a ring. Deimos, meanwhile, is slowly moving away. Currently, several rovers are operating on the Martian surface, such as NASA's Perseverance and Curiosity. They act like geologists, roaming, drilling, sampling, and analyzing on Mars, searching for signs of past or even present life. They are our robotic scientists at the Martian outpost. Mars is the next grand target for human crewed landings. It carries the dream of humanity becoming an interplanetary species, although the path to terraforming Mars is long and arduous. This red planet is undoubtedly the most likely place in the universe for us to establish a second home. Between the orbits of Mars and Jupiter lies a vast region. Here, countless bodies of various sizes and shapes are scattered. They are the asteroids. This region we call the main asteroid belt. Asteroids are the leftover building materials from the early formation of the solar system 4.6 billion years ago. The solar system was born from a giant nebula. Material in the nebula coalesced under gravity, forming numerous planetesimals. These planetesimals collided and merged, eventually forming the planets we see today. However, in the region between Mars and Jupiter, the massive gravitational disturbance from Jupiter prevented these planetesimals from aggregating into a large planet. They collided, often fragmenting rather than merging. Thus, These fossils of the solar system were preserved, forming the asteroid belt we see today. Please don't be misled by movie depictions. The asteroid belt is not an impenetrable field of debris through which spacecraft must navigate perilously. In reality, it is incredibly empty. The average distance between asteroids is over 1 million kilometers. Probes can pass through easily without needing to dodge. The largest object in the asteroid belt is Ceres. It is now classified as a dwarf planet. Its diameter is about 940 kilometers. It is the only object in the asteroid belt whose own gravity is sufficient to make it spherical. It might have a differentiated internal structure, and possibly even a layer of liquid water underground, besides main belt asteroids. There are other groups of asteroids in the solar system, for example, the Trojan asteroids that share Jupiter's orbit, and near-Earth asteroids whose orbits intersect Earth's. Monitoring and studying near-Earth asteroids is of great importance for protecting Earth from impact risks. Speaking of asteroids, we must mention meteorites. They are fragments of asteroids or meteoroids that survive passage through Earth's atmosphere and land on the surface. Studying meteorites is like directly touching pristine samples of the solar system. They provide us with the most direct evidence about the origin and age of the solar system. Next, we need to focus on a special category, dwarf planets. This is a new category formally defined in 2006 by the International Astronomical Union. To be a dwarf planet, 3 conditions must be met. 1. Orbits the Sun. 2. Has sufficient mass for its self-gravity to overcome rigid body forces so that it assumes a hydrostatic equilibrium nearly round shape. 3. Has not cleared the neighborhood around its orbit. The creation of this definition was directly related to an old friend of ours, Pluto. Since its discovery in 1930, Pluto had been considered the 9th planet of the solar system, but with advances in observation technology, we discovered more and more Pluto-like objects in the Kuiper Belt and beyond, like Eris, which is even slightly more massive than Pluto. If Pluto were a planet, then these newly discovered objects should also be considered planets. The list of solar system planets would become long and confusing. Thus, the astronomical community redefined the term. Because Pluto did not meet the cleared its orbit condition, it was reclassified as a dwarf planet. This was not a demotion, but a more scientific classification. Pluto itself is a fascinating world. In 2015, NASA's New Horizons probe flew by Pluto, revealing its true face. It is not a dead ice ball, but a world with complex geological activity. It has towering mountains made of water ice, vast plains of nitrogen ice, and possibly even a subsurface ocean. On its surface, there is a large heart-shaped region named Tombo Regio after Pluto's discoverer. The left side of this region is a young, craterless plain, hinting at possible recent geological activity. Pluto also has a complex atmosphere composed mainly of nitrogen, methane, and carbon monoxide. Besides Pluto and Ceres, other famous dwarf planets include Haumea, which is shaped like a football and even has a ring system, Makemake and Eris, both more distant than Pluto. The discovery and study of these dwarf planets have vastly expanded our knowledge of the solar system's frontier. Asteroids and dwarf planets, they may seem insignificant, but they are living dictionaries of solar system history. They preserve memories from the solar system's infancy. Studying them means tracing our own origins. Leaving the asteroid belt behind, we enter the outer solar system. The first to greet us is a true giant. It is the undisputed king of planets in the solar system, Jupiter. Jupiter's volume is 1,321 times that of Earth. Its mass is 2.5 times the combined mass of all other planets in the solar system. It is a gigantic ball of gas, composed primarily of hydrogen and helium, very similar to the composition of the Sun. In fact, if its mass were about 80 times greater, nuclear fusion could have ignited in its core, turning it into another star. In that case, our solar system would be a binary star system, because Jupiter so massive and rotates extremely fast. A Jovian day is only 9 hours and 50 minutes. Its shape is not a perfect sphere, but a distinct oblate spheroid. Its equatorial diameter significantly longer than its polar diameter. Jupiter's most famous surface features are its spectacular, colorful cloud bands. These bands, parallel to the equator, are products of violent convection in Jupiter's atmosphere. The brighter regions are called zones, where ammonia ice clouds are rising. The darker regions are called belts, where clouds of more complex composition are sinking. Chemical compounds in Jupiter's atmosphere, under the influence of powerful lightning and ultraviolet light, undergo complex reactions, producing compounds of various colors, thus painting this magnificent giant canvas. In Jupiter's southern hemisphere, there is a famous storm system larger than Earth, the Great Red Spot. It has been continuously observed for at least 350 years. This is a giant anticyclonic storm with wind speeds reaching hundreds of kilometers per hour. However, recent observations indicate the Great Red Spot is slowly shrinking and its color is changing. Whether it will disappear in the future remains unknown. Jupiter possesses a powerful magnetic field, the strongest of any planet in the solar system. Its magnetosphere is incredibly vast. If it were visible to the naked eye, its apparent size in the sky would be larger than the full moon. This powerful magnetic field traps vast numbers of high-energy charged particles, creating intense radiation belts. This poses a serious challenge for any spacecraft attempting close-range observation of Jupiter. Jupiter is also a planet that generates heat. The heat it emits from its interior is greater than the heat it receives from the Sun. This heat primarily comes from the slow release of its primordial formation heat and the gravitational potential energy released as helium droplets sink through the ocean of liquid hydrogen. This internal heat source drives Jupiter's complex and violent atmospheric motions. Jupiter is not just a planet, it is a mini-solar system. It has a vast family of moons. Currently, 95 are known. The 4 largest are called the Galilean moons because they were first discovered by Galileo Galilei in 1610. These 4 moons are each fascinating worlds in their own right. Io Jupiter I is the most volcanically active body in the solar system. Its surface is covered with active volcanoes. constantly erupting sulfur and sulfur dioxide. This is because it undergoes intense tidal heating from Jupiter and the other moons, causing its interior to be constantly churned and heated by friction, making it like a pizza continuously heated in a microwave. Europa Jupiter, too, has a surface of smooth ice crust, covered with a network of intersecting cracks. Beneath this ice crust, there almost certainly exists a global liquid water ocean. The volume of water in this ocean might be more than all of Earth's water combined. Because tidal heating provides energy, Europa's deep ocean is considered one of the most likely places in the solar system to host extraterrestrial life. Ganymede, Jupiter 3, is the largest moon in the solar system, even larger than Mercury. It is the only moon known to have its own magnetosphere. It is also a world with a subsurface ocean, and its internal structure is very complex. Callisto, Jupiter 4, has a surface covered with ancient craters, one of the most heavily cratered surfaces in the solar system. It too might have a subsurface ocean, but its geological activity is relatively quiet. Jupiter's moon system, so rich and diverse that it itself constitutes a complete world worthy of in-depth exploration. Additionally, Jupiter has a faint planetary ring system, composed mainly of dust particles kicked up by impacts. Not as spectacular as Saturn's rings, but they exist. In the evolutionary history of the solar system, Jupiter has played a dual role as protector and disruptor. Its immense gravity likely cleared out much of the debris from the inner solar system, aiding the formation of Earth. At the same time, it might have flung some small bodies into the inner solar system, causing impact events. But overall, its presence acts like a giant gravitational broom to some extent, shielding Earth from catastrophes originating in the outer solar system. Flying past Jupiter, we continue our journey to the outer solar system. The next stop is a planet almost everyone can recognize at a glance. It possesses the most magnificent and enchanting rings in the solar system. It is Saturn. Saturn is the second largest planet after Jupiter. It is also a gas giant, composed mainly of hydrogen and helium. Its density is very low. It is the only planet with a density less than water. If you could find an ocean large enough to hold it, it would float like a ball on the water's surface. Of course, Saturn's most striking feature is its ring system. These rings are not a solid disk, but consist of countless particles of ice and rock of varying sizes. These particles range from dust-sized to as large as a house. They all orbit Saturn on their own paths. From a distance, they form a smooth, bright ring system. The structure of Saturn's rings is extremely complex. They are divided into several major rings: a ring, B ring, C ring, etc., with distinct gaps between them. The most famous gap is the Cassini division, discovered by astronomer Giovanni Cassini in 1675. These gaps are often cleared by gravitational resonances with Saturn's moons. The moon's gravity acts like shepherds herding sheep, pushing ring particles away, forming clear lanes. Saturn's rings are very broad. Their diameter from inner to outer edge is over 200,000 kilometers, wide enough to fit more than a dozen Earths side by side. But they are also very thin. The average thickness is likely only about 10 meters. Relative to their width, they are thinner and a sheet of paper. The origin of Saturn's rings is still debated. The leading theory suggests they might be the remnants of an icy moon torn apart by Saturn's tidal forces, or they could be primordial material that failed to coalesce into a moon during the solar system's formation. Based on data from the Cassini probe, Saturn's rings might be relatively young, forming between tens of millions to 100 million years ago, very young on astronomical timescales. Saturn itself is also an active gaseous planet. Its atmosphere shows banded structures similar to Jupiter's, though with a more yellowish-brown hue. Saturn has the highest wind speeds in the solar system. Wind speeds at the equator can reach up to 1,800 kilometers per hour, similar to Jupiter. Saturn has an internal heat source, releasing more energy than it receives from solar radiation. This also comes from the release of primordial heat and the settling of helium rain. Saturn also boasts a large family of moons. 146 have been confirmed so far. The most fascinating among them is Titan Saturn VI. Titan is the second largest moon in the solar system. After Ganymede, its most unique feature is that it is the only body in the solar system, besides Earth, to have a thick atmosphere and stable liquids on its surface. Its atmosphere is composed mainly of nitrogen. The surface pressure is 50% higher than Earth's. Beneath its orange haze lies a magical world here. There are lakes and seas of liquid methane and ethane, mountains made of water ice, eroded by rivers of liquid hydrocarbons, a weather cycle featuring methane rain, and even the potential for prebiotic chemicals made from liquid hydrocarbons. It is a natural laboratory for testing hypotheses about the origin of life. In 2005, the Huygens probe, released from the Cassini spacecraft, successfully landed on Titan's surface, sending back the first-ever images from the surface of an extraterrestrial ocean world in the future. There are plans to send drones or submarines to explore Titan. This mysterious world is full of limitless possibilities for imagination. Besides Titan, Saturn's other moons are also unique. For example, Enceladus Saturn II, with its icy volcanoes spewing water ice particles. The ocean beneath its icy crust might also host life. Then there's Hyperion Saturn VII, shaped like a walnut, and Mimas Saturni, resembling the Death Star from Star Wars. These peculiar moons together constitute Saturn's magnificent family. Saturn, with its rings and moons, forms a cosmic-scale work of art. It fills us with awe for the wonder and beauty of natural laws. Our journey continues further into the cold depths of space. Next, we will visit the two ice giants. They are different from the gas giants. They lack a thick layer of liquid metallic hydrogen, instead possessing a core made of icy materials like water, ammonia, and methane. First, Uranus. The discovery of Uranus was a milestone in astronomical history. It was the first planet discovered with a telescope, found accidentally by William Herschel in 1781. This discovery shattered the traditional view that Saturn was the boundary of the solar system, vastly expanding humanity's cosmic horizon. Uranus's most unique characteristic is its axial tilt. Its rotation axis is almost lying on its side relative to its orbital plane. The tilt is a whopping 98 degrees. This means on Uranus, one pole faces the sun continuously for 42 years, followed by 42 years of continuous night. The other pole experiences the opposite cycle of midnight sun and polar night. It's like a ball rolling along rather than a spinning top. Why does Uranus rotate on its side? The most plausible explanation is that early in the solar system's history, it was struck a violent blow by an Earth-sized object. This impact completely altered its rotational posture. Externally, Uranus appears a faint blue-green color. This is because methane in its atmosphere absorbs red light and reflects blue-green light. Compared to the active cloud bands of Jupiter and Saturn, Uranus's surface appears exceptionally calm, with few visible storms or cloud band structures. This might be related to its lack of significant internal heat. Its internal heat seems very low. Uranus also has a ring system, but its rings are very faint and narrow, composed mainly of dark particulate matter. They weren't discovered until 1977 through stellar occultation observations. Uranus has 28 known moons. Most of their names are taken from characters in the works of Shakespeare and Pope. For example, Titania, Uranus 3, Oberon, Uranus 4, etc. These moons themselves are also icy worlds composed of water ice and rock due to its great distance. Our understanding of Uranus still very limited to date. Only the Voyager probe has flown by it. In 1986, it provided most of the data we have on this ice giant. Future missions, specifically dedicated to exploring Uranus and Neptune, are being planned. This mysterious sideways planet holds too many secrets waiting to be uncovered. Beyond Uranus lies the outermost major planet of the solar system. Its discovery was a great triumph of mathematics and Newtonian mechanics. It is Neptune. After Uranus was discovered, astronomers found that its observed orbit deviated from the theoretical orbit calculated using Newtonian gravity, so they predicted that beyond the orbit of Uranus, there must be another unknown planet. Its gravity was perturbing Uranus's motion. To brilliant mathematicians, John Couch Adams in England and Urbain Le Verrier in France, independently, through mathematical calculation, predicted the position of this unknown planet. In 1846, German astronomer Johann Gottfried Galle, using the position calculated by Le Verrier, successfully found this new planet in his telescope. It was named Neptune after the Roman god of the sea. Neptune's size and mass are very similar to Uranus's. It is also an ice giant. Its appearance also shows a beautiful blue color, again due to methane in its atmosphere, absorbing red light, but Neptune's blue is deeper and more vivid than Uranus's. The reason is not fully understood, perhaps related to other unknown atmospheric components. In stark contrast to the calm Uranus, Neptune is a world of extremely violent weather. Even though it is the farthest from the sun, receiving the least solar radiation, its interior seems to have a powerful heat source, driving the strongest storms in the solar system. When the Voyager probe flew by Neptune in 1989, it captured a great dark spot in its southern hemisphere, called the Great Dark Spot. It was comparable in size to Earth, This was a giant storm system similar to Jupiter's Great Red Spot. Wind speeds reached up to 2,100 kilometers per hour, the fastest recorded in the solar system. However, later observations by the Hubble Space Telescope showed the Great Dark Spot had disappeared or weakened, indicating that Neptune's atmospheric activity changes very dramatically. Neptune also possesses a ring system, similar to Uranus's rings. They are also faint and discontinuous. Composed of a few bright arcs, these ring arcs are able to maintain their structure, likely due to the shepherding gravity of nearby moons. Neptune has 16 known moons. The largest and most interesting among them is Triton Neptuni. It is a world with active geology, possessing polar caps of nitrogen ice and cryovolcanoes erupting nitrogen gas and dust. Even more peculiar, Triton's orbit is retrograde. This means it likely did not form alongside Neptune, but was captured by Neptune's gravity from the Kuiper Belt. Neptune, as the current boundary of the solar system's major planets, represents the power of human reason. We did not find this distant world with our eyes, but with our minds and mathematics. It guards the known territory of the solar system, gazing out towards the more distant, unknown frontier. Our planetary tour concludes here at Neptune, but the solar system's domain extends far beyond. Beyond the orbit of Neptune lies a vaster, darker, and more mysterious realm. First, the Kuiper Belt. This is a disk-like region similar to the asteroid belt, but vastly larger in extent. It starts from Neptune's orbit about 30 astronomical units, extending out to about 55 astronomical units from the Sun. It is filled with countless icy small bodies, composed mainly of water ice, ammonia ice, and methane ice. They are also primordial material, left over from the early formation of the solar system. Pluto is one of the most famous members of the Kuiper Belt. Besides Pluto, there are dwarf planets like Makemake and Haumea here, as well as tens of thousands of trans-Neptunian objects. Beyond the Kuiper Belt lies the more distant, scattered disk. Objects here have more elongated and inclined orbits. They were likely scattered into this region by the gravity of the giant planets early in the solar system's history. And the most distant frontier of the solar system is a hypothetical, enormous spherical cloud, the Oort cloud. It is thought to be the source of long-period comets. Its inner edge is probably about 2,000 astronomical units from the Sun. Its outer edge might extend to more than 1 light-year from the Sun. Here, there could be trillions of icy comet nuclei. They are bound by the Sun's gravity, albeit extremely weakly. Occasionally, gravitational perturbations from passing stars or the tidal forces of the Milky Way galaxy push these comets into the inner solar system, bringing us uninvited guests with long tails. Comets are often called dirty snowballs. They are mixtures of ice, dust, and rocky particles. When they approach the Sun, the solar heat causes ices on the comet nucleus to sublimate, ejecting gas and dust, forming a huge, diffuse coma. And, under the influence of the solar wind and radiation pressure, forming one or more long tails pointing away from the Sun. Comet tails can be over 1 astronomical unit in length, one of the most spectacular astronomical phenomena in the solar system. Studying comets is highly significant because since the birth of the solar system, they have been preserved in the cold frontier, virtually unchanged. They carry the most primitive components and information about the solar system. For example, the famous Rosetta probe once accompanied Comet 67P Churyumov-Gerasimenko and deployed a lander to its surface. Analyzing its composition, it provided key clues for understanding the origin of the solar system and the source of Earth's water. And so we have traveled from the fiery center of the sun all the way to the Oort cloud over a light year away. We have reviewed this vast and intricate family of the solar system. There are stars, planets, moons, asteroids, comets, countless icy worlds, all moving in an orderly fashion under the law of gravity. Looking back on this journey, we can't help but ask, how do we know all this? The answer lies in humanity's millennia of relentless exploration of the stars, from ancient Babylonian records to Greek models, from Copernicus's heliocentrism to Kepler's three laws, from Newton's universal gravitation to Einstein's relativity. Our understanding has been and expanded step by step. But what truly allowed us to visit these worlds was the dawn of the space age. Starting from the mid-20th century, humans have launched countless space probes. They are like brave messengers that have flown by all the classical planets. Some orbited, some landed, some only captured a fleeting glimpse, but the data and images they sent back collectively painted the picture of the solar system we know today. Voyager 1 and Voyager 2, launched in 1977, undertook one of the greatest journeys in the history of space exploration. They utilized a rare planetary alignment and the gravity assist technique to fly by Jupiter, Saturn, Uranus, and Neptune in succession, completing the grand tour. Afterwards, they continued their flight out of the solar system. Voyager 1 has crossed the heliopause, entering interstellar space. It became the first human-made object to reach interstellar space. On board these spacecraft is a gold-plated record called The Sounds of Earth. It contains sounds, images, music, and greetings from Earth. They are like cosmic messages in a bottle, carrying information about human civilization, sailing into the boundless ocean of stars. Even though they might never be found, the act itself represents humanity's yearning and greeting to the universe looking to the future. The exploration of the solar system still in its ascendance. We will return to the moon, establishing permanent bases. We will set foot on Mars, leaving the first footprints. We will send probes into the oceans of Europa and Enceladus to search for traces of life. We will launch more advanced telescopes and probes to unravel the mysteries of Uranus, Neptune, and the Kuiper Belt objects. Even the dream of flying out of the solar system is already being contemplated. The solar system is our cradle, but humanity will not stay in the cradle forever. This ocean of stars is full of unknowns and challenges, but also full of opportunities and hope. Every time we look up at the cosmos, we recognize our own insignificance. Every time we advance into deep space, we prove the greatness of our civilization. Well, dear listeners, our long tour of the solar system must now come to a temporary end. We started from the sun's fury, across the rocky worlds of the inner solar system, marveled at the majesty of the gas giants, visited the mysterious profiles of the ice giants, and finally reached the cold, distant frontier of the solar system. I hope this journey has given you a more comprehensive, three-dimensional, and vivid understanding of this cosmic corner we inhabit. The universe is vast, and we are small, but it is we, the small ones, who possess the ability to comprehend this immensity. Thank you for listening and accompanying me on this journey. I am your guide to the sea of stars. Until our next cosmic voyage, farewell. All right, my friend, let's pause our conversation here tonight on the mysteries of the universe. Now, allow me to press pause for you. Set aside all thoughts and inquiries, and simply, quietly be in this moment. From here, my voice will fade away, leaving only the silent tapestry of the cosmos and a carefully chosen piece of pure music tuned to 432 Hz. Science suggests this frequency resonates deeply with the natural vibrations of the universe and the rhythm of life itself, soothing your nervous system and guiding you into deep relaxation. Now, find your most comfortable position. Gently close your eyes or let your gaze rest softly upon the stars. May you release all weariness from the world, letting your consciousness drift on the waves of music, floating into boundless tranquility. Good night, sweet dreams, until we meet again among the stars.